Welcome to the channel, Infinite Exploit, where we learn and have fun. Let's get started and Brody, please don't forget to like, comment, and subscribe. Love you guys.
So now we're going to talk about functions in C++. Now, now a function is basically a collection of code that performs a specific task. So in C++, sometimes you may have code that does a specific thing. Now, a function is like a container where you can use that code and you can call it continuously. So let me give you an example. So this right here is a function. So this block of code performs a specific task. Now, this gets executed when we run our program. So any code that we put in here will be executed. So let me show you how we create a function. Now, this function is going to say hi to a user. So we need to give C++ a couple pieces of information. So the first thing we want to do is give it a return type. So sometimes it'll return values, but we'll talk about return types in the next video. So if we do void, it just means that the function is not going to return anything. Now we're going to give it a name. So generally when we name the function, I want to name it regarding the task that it's going to perform. So I'm going to have it say my greeting. So any code that I put in between this open and closed curly bracket would be in our function. So I'll say hello there. Now let's run it. So let's compile it. And when we run it, it's not in print out. So if we want this to get executed, we need to call the function. So this will get executed no matter what. So I can do my greeting. It's just saying I want to execute all the code up here. Okay. So let me recompile it. Now you see it's print out hello there. So up high. Down low. So I can show you how this works. So it runs this first since it's the main function. It looks for the function we just created and it pulls that string of text, and then it runs this line of code. So we can also give it parameters. So what if we want to specify that we want to give it information? So what if we say hello to someone specific? I can do string name, and I can have it accept one parameter. So I can say hello name. So all right, so I'm gonna give it an argument, and I'm gonna say Tim. All right, and say hello Tim. All right. What if we want to go ahead and give it um, two pieces of information, like age as well? And I'm gonna specify say integer. So I do int age is what I'm naming that variable. Then I'm going to say you are, and then I'll say age. Right. And when I call the function, I'm gonna give it two pieces of information. So I'm gonna say 50. So when I call it, it should take in both of those pieces of information and it could perform this task. Hello Tim, you are 50, right? And I can copy this as many times as I want. And I can say, for example, Jim, Ben, Kelly. So we can reuse this code. I write the function one time and I can continue to reuse it, right? So let me show you this. Recompile it. You see. So now if I took this code, right, this function, and I put it down here, we'll get an error because it doesn't know about this function. It wasn't created, right? We created it at the bottom. So we can also do a function signature up here. So that way, so like you know how we create a integer like this, right? We're gonna declare it, and I'm gonna define it down here. So for example, we'll say void my greeting. So I can do that, right? And now it should be able to run. Now I'm gonna show you how we can get information back using the return keyword in C++. Okay. So we can write function like we just did. Now we can pass in information like we talked about. Now it can also give us back information. So Now I'm going to show you how we can use this, how we can use that return keyword. So what if we create a function up here? So if we cube a number, we take it to the third power. So for example, we go right. That's equivalent to right. So last time we did void. That means it's not going to return information. So we want to return information. So we can do int or double. We can do character. So we're going to do double since we're just cubing a number. Cube, and we're going to take one parameter. We're going to say double. We're going to say num, and inside of this function, we just want to cube the number, and then we're going to have it result equal to num times num times num. Now I'm going to return. So I can say return result. That just means you want to return this result back to the person that's running the program. So for example, if I do cube and I give it 6, I can say double answer, right? And I can see out answer, and I should be able to print out cube and 6, right? Right. So I also can do it this way. So when we do the return keyword, that means that we're done printing out the code. So for example, if we do, let's see, return right here, and then we want to print test, it's not going to print this, right? It's not going to print it. Oh, I'm sorry. I don't have to do the equal operator with return statement. All right, so it didn't print test. It just print cube and at double. So it breaks us out of the function when we do this. It's not going to reach this, right? It breaks out anyway down to the main function. So that's why the return. We can return strings, integers, and we can store information there as well. Now, I'm going to talk about if statements in C++. So it allows us to respond to different situations. So we're able to check conditions. If it's true or false, it can do certain things. So I'm going to show you how it works. So in our main function, I'm going to go ahead and create a variable. So I'm going to do a Boolean variable. So it stores a true or false. So I'm going to say it's tall, and I'm going to say it's true. Now I'm going to show you how we can use the if statement. It lets us respond to different situations. So I can write the if statement, determine if a user is tall or if they're not. So if I say if, we do open and close parentheses, open and close curly bracket. So in here is what we're going to put the condition, right? So we're doing a true or a false value. It's a condition. So if I say it's tall, so it's a if the value in here is true, then we're going to execute the code inside here. So I'm gonna say you're tall. So it say you're tall. So if I do false, it won't get printed out because the condition is false. It's not going to execute that code. So we want to handle that as well if they're not tall. So if I say, for example, I can say else. So if this is false, I'm gonna say see out, you're short. All right. So none of the program is smart enough to respond if it's false. So it said you're short. Okay. So I'm gonna show you how we can make this a little bit more complex. What if we added another boolean, and I'll say this bool is smart. I can say true. So I can say if tall and if they're smart, I'm gonna say you're tall, you're tall and smart. So both of these have to be true, right? It should print that first line. You're tall and smart, right? I'm gonna say you're smart but not tall. So if this is true and this false, it should print the second line, right? Now I can do or comparison. These are comparison operators. We're gonna talk about switch statements in C++. Now switch statement is like a special type of if statement where we can check one value with multiple other values. So I'm gonna show you with an example of it. So in this program, I want to create a function that can convert a number to the day of the week. So if I do 0, I want it to print out Sunday, right? And if I do 1, Monday. Okay, so let's go ahead and create this. I'm gonna have a string and I'll call it get weekday, and I'm going to have an integer, and I'm going to have it take a day. So inside of this function, we need to return a date depending on the integer that they give us. So string day name. Now I'm going to return day name. So we can do an if statement. So for example, if day num is equal to 0, then I can say day name equal to Sunday, and I can do this for 0, 1, 2, 3, 4. Right? I will have to create about 8 of these. So this will be one of the best circumstances to use a switch statement. So in every one of these conditions, we're checking to see if the same value of day num is equal to a certain integer. So like equal 1, 2, 3, 4. It's a perfect candidate for a switch statement. So I'm gonna go ahead and write switch, and I'm gonna put in a value that I want to compare. So I'm gonna do day num. I want to compare it to these other. So I can do cases. I can do a 0 and a colon, and I can say day name. So in the case that day num is equal to 0, then it's Sunday. And I could break. And then case 1, I can do this Monday. So it's going to break us out of the switch statement when we use this break function here. So it's good to say break unless you want to check for more than one condition. So I'm going to make one of these, and I'll show you here. All right. Let's see here. So I would change this to 2, and this will be Tuesday. I'll change this to 3. It'll be Wednesday. 4, Thursday. Case 5, Friday. And then case 6 will be Saturday. All right. So we also need, if someone create or enter an invalid number, we need to have a special option. So we're going to use default. If none of these cases appear, then it's going to do this. So I can say day name is equal to invalid. So it's really clear, really easy to do this. So if I do cout, and I'm going to do get weekday, and I'm going to pass out 0, right? Put my return inside of here, take it off here, and I'm going to save this, and I'm going to compile it, and it should give us Sunday. Let's see. Okay. I always in your instructions with a semicolon, you guys. All right, clear screen. Now let's test it. Oh, snap. They give Sunday, as you can see there. So what if we pass it 4? We save it, recompile it, Thursday, right? Let's do an invalid number. Let's do 20. Invalid, right? So let's talk about while loops now. That allows us to loop through certain conditions as long as it's true. So, I'm going to show you what it does, and we'll be able to see what it does. So I'm going to create an integer, and I'm going to do index equal to 1. This is just used as an example. It's not necessary. So I'm going to say while, open, close parentheses, open and close curly brackets. So inside these parentheses, we're going to specify a condition. So we're putting a condition, just like an if statement. And as long as that condition is going to be true, it's going to execute these instructions outside of here. As long as it's true, it's going to keep looping through that code every time it's true. So I'm going to show you this right quick. So I can write a condition. So I'm going to say while index is less than or equal to 7. So I'm going to execute code inside of here. So I want to print out a value. So I do cout index, new line, index plus plus. And this is going to add 1 to it, okay? Go ahead and run this. I'm going to recompile it, and I'm going to run it. So you got 1, 2, 3, 4, 5, 6, 7. And I told C++ while is less than or equal to 7, it keep looping over this code. So since that's true, 1 is going to print out 1, and then we add 1, then it's 2, still less than 7, then 3, and 4, right? So for example, so if I don't add anything else to it, right? For example, let's say I say that like this, that's going to be an infinite loop. It's just going to keep going, right? And sometimes attackers may use a technique like this to create a denial of service because it's continue to or fork bomb, where it's continue to execute processes over and over and over and over again until program crashes. So now we're going to talk about for loops in C++. So it allows us to keep track of looping through index variables. So like arrays, like we talked about, if you have certain elements, we can go through each one and we can check. So I'll give you an example here in just a moment, so that way you can see exactly what this will be. So what I'm going to go over with you now is a for loop, and it's a type of loop. It lets us know how many times we have gone through the loop. We can use an index variable. That way we can keep track of how many times we go through the loop. So we can also do it for other stuff. So right here we have a simple program. It's a while loop. It's a integer with index variable, and it's going to continue to go through this. Let me go ahead and compile this so I can show you exactly what this does. Every time it goes through the loop, it lets us know which one that it goes through. So like for example, 1, 2, 3, 4, 5. So it tells us what iteration of the loop that we're currently on. So a lot of times, keeping track of how many times we go through the loop is very useful. So it's a special type of loop that provides us with a type of structure every time this index value changes. So let me show you how we can do a for loop. It's going to be exactly this, but it's going to be a lot more compact. So we do for. So instead of here, we just have this in this condition, right? We're going to put a couple things in this for loop. So I'm going to go ahead and do int I equal to 1. So this is going to be this same thing as index. I just call it I. I'm going to do a semicolon. We're going to put another line. I'm going to do a loop condition. So that's the next thing we want to add. So we already declared this variable, right? And we're going to put the looping condition. So let me add that part. I is less than or equal to 5. And then got this variable, then we got the condition. Now I want to put in a line of code that's going to get executed after each iteration. So I do I plus plus. That's shorthand for this. So I want to increment index. All right. I can also do I minus minus as well. So inside this for loop, we put whatever we want to do on each iteration. So it'll be similar to this right here. So this loop is equivalent to this loop. So I'm gonna go ahead and save it, compile it, and run it. So as you see, it ran twice. You see, one through 5 and 1 through 5. So if I got rid of this, just so you can see, and I save it, and I'm gonna do. I took the main function part out. All right, let's save it, and then I'll show you. See, 1, 2, 3, 4, 5. So I'm gonna show you how we can iterate through array. Go through. So what if we do a nums array, and I want to do 2, 4, 6, 8, 10. So if I say num 0, access that 2. If I do 1, it's gonna print out the 4, right? So array index is start at 0. So it's gonna say I is less than number in the array, right? Instead of print out I, I'm gonna print out nums. All right, so let's save it, compile it. So it loops through all the elements in the array, right? So let me change this to 1 so you can see what we get. They're very useful. So it's only print these two values because 0 and then 1 is less than 1. So it's only gonna print the first index and the second index, right? So now we're gonna talk about exponent function. It's gonna be a function that takes a number to a certain power. So for example, if I do 3 and 5, it'll be like 3 raised to the 5th power, right? So it'll be similar to that. So I'm going to do integer. I'm going to call it power, right? Because it's raising number to a certain power. We're going to have a base number and we're going to have a power number. So I'm going to do int base num int power num. Now I need to take int base num to int power num. So we can do a for loop to do this. So I'm going to go ahead and do int result equal 1, and we'll return the result. So how would we do this? So if we did for loop, we need to specify three things. So I'm going to say int I equals 0. If I want to keep looping, I want to do as long as I is less than power num. So if power num is 3, I want to loop through it 3 times. If it's 5, I want to loop through it 5 times. Then I want to do iteration. So I'm going to I plus plus. It's incrementing after that. So we want to do our instructions here. So result equal result time base num. All right. So I'm going to save it. All right. And then we'll see what we're getting so far. So so let me go ahead. I'm gonna put this up here, and I'm going to call it in the main function. So I'm gonna be able to handle positive numbers. So let me go ahead and call this. So I'm see out power. I'm gonna pass and 4 and 5. All right. All right. So yep. Got that. Save it. Compile it. Let's see. All right. So we got our function. It's passing in two parameters, base num and power num. And result equals 1 for int I equals time base num. Okay, I forgot my semicolon. All right, let's compile it. Let's see what we got. Yeah, so it took 4 to the 5th power. So now we're going to talk about two-dimensional arrays. Okay, so inside our main function, we're going to have an integer, and we're going to name it number grid. And this is going to be an array, right? We named our variable this, and I do 3, 2, and inside of here. So this is basically specifying how many total elements we're going to have. So for example, inside of here, let me give you an example here. So what if I do 2 and 4, and do comma 3 and 5, and do 6 and 7. So this is 1, 2, 3, right? And inside of here, this 2 is specifying 1, 2, okay? So I can actually print this out, right? So if I did C out number grid, I can access this 0, and I can do 1, right? And this should print out 4 because this is 0, 1, 2, and then 0, 1. All right. All right. So let's go ahead and compile this. Let's see. All right. So let's talk about nested for loops. That means we have a for loop inside of a for loop. So we can iterate through the elements inside of here using a nested for loop. So let me show you how we'll do that. We'll do for int I equals 0, and I want to do I less than 3. I want it to loop through each one of these, right? And I want to do I plus plus. So first, second, third. For each one of these, I want to each. I want to also go through each element in there too. So we'll do for int x equals 0, and then I'm going to do x less than 2. It's going to go through these elements, and then I'm going to say x plus plus. So, and I'm going to see out. It's going to print out these different elements. So number grid, and I'm going to do I, and I'm going to do x. All right. So right here, I want to see out. So with new line, let's save it. Let's compile it. Let's see what we get. So it's 2, 4, 3, 5, 6, 7. So I'm able to go through every element inside this two-dimensional array. So anytime I go through the I loop, we're fully iterating through the X loop as well, right? So the X is going to do the inside, right? This I is these 0, 1, 2, right? So let's talk about comments. So a lot of times you want to write things that you won't need. So for example, if we do see out, I'm going to say, what is a comment? Essentially, it's a line of code that's not going to get executed. So when I create one, we're just 2 forward slashes. I'm going to say, this is a comment. So anything after those forward slashes comment, right? It's not going to execute. So if I save this, it'll say what is comment. Sometimes you might write notes themselves. Sometimes you might explain a line of code. Uh, so it's only working on one single line. If we want to do a multi-line comment, we'll do it like this. We'll do forward slash asterisk. All right, and if I do enter, then this will be multi-line. So it'll be we can do a lot of comments, right? For example, that's a multi-line comment. So now we're going to talk about pointers in C++. So we don't work with integers, doubles, and strings. So I'm gonna tell you how we do this. So let me go ahead. Pointers is basically memory addresses, right? So let me go ahead and declare some variables. So I do age equals 25. I do double GPA, and I'll make it a 2.0. And I do a string name equals Timmy. So that way we have a string, integer, and a double. Okay, equals. And I'm gonna show you how we do this. So all of these are variables. See, these are containers where we're storing specific information. So we're storing 25 in the age variable. We're storing 2.0 in this GPA variable. So what's going on? We have memory in the computer. Sometimes you may hear it called RAM, which is random access memory. So anytime your computer runs a program, it's using RAM, it's using memory. So in case of this program, the computer will be using RAM. So it's going to use memory to store this information. So it's going to store all this in memory. So when I create age and give it a variable, it's going to take this value here. It's going to store inside the physical memory of the computer. So it's going to take this physically inside of the memory. So same thing with the string as well. All of it's getting stored inside of memory, inside the computer. So when we do it, we say age is stored at 25. So we have those containers. But inside the hood, the computer store it in the memory. So 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 if I wanted to print out, I can print out the memory address where these variables are stored. So I can do C out. And the way we'll do this is I do ampersand, and I can type in the name of the variable. So if I do age, it's going to tell C++, I want to print out the memory address where the age variable is stored. So where 25 is stored. And I'm going to save it. So I'm going to save it. All right. And this is a hexadecimal number. So if I were to go to this physical memory address, you'll find the value of 25. That's essentially what this is doing. That's where it lives inside of this memory. If I want to change or modify it, I can do it with this. And in C++, we have a word for these addresses. It's called a pointer. So if we're working in C++, we're talking about memory addresses, we're talking about pointers. So this would be a pointer, right? It's a type of information. It's a memory address. So it's going to be called a pointer. And the way we can access the pointer in the memory addresses is by using this ampersand. So I'll show you a demonstration. So what if I wanted to print out memory addresses for other ones? I do GPA, I do C out and name, right? And then it should print out 3 memory addresses, right? So yeah, if I wanted to put this on a new line, what I can do is do this. So that way they won't be all running together, okay? So that's why we add this. And now I'm gonna save it. So my shortcut is Control C. Y'all see me physically save it right there, just to remind you, just in case you're not using shortcut. Perfectly fine. And they're all printed out on different lines. Okay. So I can create a variable where I can store a pointer. So how we have this integer, I store the integer. I have a double variable, store the double, and string, store the string. So I can create a pointer variable. Let me show you how we can do that. It's a container where we can store a memory address. So generally, when we're working with a memory address, we're not doing random address. We don't really know them. So when we use memory addresses, we're going to be using memory addresses of the variables. So we're going to create a pointer variables inside of the that's like a container. It's going to be based off of these variables that we create here. So let me give you an example. So if I do int, you want to use asterisk anytime you do a pointer variable, and I do ph. A lot of times you use lowercase p, and then you'll put in the name of the variable when you want to store it. And we're going to do equals ampersand age. And that gives us every time we use this ampersand, it's going to give us a memory address where it's stored. And I can do the same thing for this double as well. I can do double asterisk pgpa, and inside it, it's storing this memory address. So I can do the same thing with string. I can do string pname, and now pname is storing a memory address of the string name, right? So if I do, for example, ph, let me save this. Let me go ahead and recompile it. You see this? So point is just a different type of data. It's a container where we store it. So whenever I create this, I use the data type of what I'm storing to. So if I say int, I say int. If it's doing a double, I'm doing double. If I'm doing a string, I'm do string. So I want to show you one more thing. We can also dereference a pointer. That means we're going to grab the value inside the memory address. So if we have a pointer, we have physical address. It's kind of like an address for your house. It's for a memory. Anytime we dereference the pointer, instead of using the pointer, I want to go to the physical memory address and grab that value out of there. So when I print out ph, it's going to give the memory address. But if I want to dereference it, I'll get the value that's stored there. So if I do an asterisk here, it's going to dereference that. So instead of getting the memory address, it should give us 25 because we're dereferencing it. So let me go ahead and recompile. So that's dereferencing. So if I did ampersand GPA, it's going to give me the memory address. So if I do, it's giving me the physical memory address. So if I do the asterisk there, it should give me 2.0. Right? Recompile. I'm sorry, got to keep the ampersand there. It's going to dereference it. So now I'm going to recompile it, and it should give us the value 2. See? So now we're going to talk about classes and objects in C++. So they're extremely useful in C++. So we're going to go over a little overview of what these are. So I'm going to go ahead and I'm going to create a few different variables right quick. I'm going to do a string name, and I'm going to call it infinite. I'm going to do double, and we're going to do 3.4 since that's the value of pi. And I'm going to do my fave letter, and we're going to do a, right? So we got a couple variables here we created. So for example, we can create our own data type. So what if we want to do a car or a phone? There's no data type like that. We have booleans, doubles, floats, characters, and strings, right? So I'm going to show you how we do that, and that's where classes and objects come to play. So I'm going to go ahead and create a function. I'm going to create a class. It is a specification or a blueprint for a new data type in a program. So I'm creating a new data type. I'm going to create a new type of data that we're going to use. So I'm going to call it class, and I'm going to usually when we name it, we're going to name it based off capital letters. So I'm going to do class car, and it's going to be a blueprint or a template for a car data type. Okay, we're going to specify what a car is. So inside of here, I'm going to define what it is. I want to give it attributes. So I can say a car can have a couple different attributes like make, model, etc., specs, everything like that. So essentially, this car class is going to be a couple things. So I'm going to do public colon. I'm going to specify. I want to map out what a car is going to be. So what are the different attributes of a car? So the title is what I do. First thing, I'm going to string title. Let's say make. I do string model. I'm going to also do int cost. We can do a lot of different attributes. So we're going to do this. I'm going to map out a blueprint. I'm going to say this is the blueprint for a car data type. Now it can have a make, a model, and it can have a cost associated with it. This is a more complex data type. So this is all we need. We want to specify what a car is. We want to tell that. Now in this main function, I want to go ahead and tell C++ what this is. So if I want to tell C++ what a car is, we're going to create an object. So a class is the specification. It's the blueprint or the template of a data type. So this is what this class is. An object is the instance of that class. So I'm going to create an object down here. So I'm going to give you an example here. And we can create a lot of objects. The class is the template, and the object is the instance of that class. Okay. So I'm going to do that. So I'm going to do car. I'm just telling C++ what kind of data I want to store, and I'm going to call it car1. And I want to start giving it some attributes. Okay. I'm going to say car1 dot make, and I'm going to say Toyota, right? And I'm going to say car1 model Camry, and I'm going to say, so I'm going to do car1 cost, and I'm going to say 30,000. So now I can print out this information. I can do C out, and I can do car1 dot make. So I should be able to print this out. So let me compile it. Toyota. Before, we didn't have a car data type. I didn't have anything I can use to represent a car in my program. Now I can represent a physical car in this, and I can go ahead and make as many as I want. So, for example, in addition to this one, what if I want to do another car? Let's say a more expensive car. I'm going to change this. Let's make this Ferrari. And let's call it Spider. So now I have car 1 and car 2. So it's using the same car template, but I'm able to create different instances. So if I see out that, it'll print out that it's a Ferrari, right? So just like before, when we had integers, and strings, now we have car, right? So we're defining car and we're giving it a title, right? So I can change it. So if I do car2 dot make, and let's say I want to do cost, and I want to call it $750,000. So it should print out that cost instead now. All right, we're gonna compile it and see it's giving a higher price now.